All right, 6.4 homework. Let's write our names on it now, please. And whatever period you're in. Currently, we're in one and 2. All right, for each of the problems below, identify the independent and dependent variables and write an algebraic rule to represent the relationship between the variables. Okay, so the rule, remember, has our equal sign. We have to have something on both sides. So first of all, we need to make sure we're doing this in function notation. So n, remember, is my independent variable. So you can write independent over here. And my cost C is dependent. Remember that my function notation, the guy in charge, goes inside the parentheses. So my function notation is going to look like n inside the parentheses, C on the outside, and then the equal sign. So we're getting fancier and fancier here by the day. We no longer need to write y. This is called function notation. If they ask for function notation, instead of writing y, you're going to write the independent variable in parentheses, he's in charge, and the dependent variable out here. So the independent variable here is n, number of CDs. The dependent variable is C, the cost in dollars. So we know the rule is going to be C parentheses n equals. Now, you've got to think about it. Which letter is going to be over here on the right-hand side? Is it going to be the N or the C? Well, the number that goes in is always this number. So remember, this is the inside of your machine over here. So this number goes in, so we're going to see N again over on this side. So if we think about it, you can try a couple different ones. I know I have to multiply by 15. 1 times 15 is 15. 2 times 15 is 30. 3 times 15 is 45. So there is no plus or minus at the end here. So if we wanted to write this rule, we could write C of n is equal to whatever your n is, in this case 1, 2, 3, times 15. This is the same exact thing as C equals 15n. Same exact thing, except for if you write this n again inside the parentheses, it's called function notation. So my algebraic rule is the cost, which is dependent on the number of CDs, is equal to $15 times the number of CDs. All right, let's try B. Chris works at Fran's frozen yogurt parlor. He earns $7.75 per hour. The amount of money that Chris earns each week depends on the number of hours that he works. So let's see. The amount of money that Chris earns is one of the variables. That depends on the number of hours that he works. So you've got to think about it. Who's in charge? The number of hours or the amount of money he earns? Well, the hours he works decides how much money you earn. So the independent variable, the guy in charge, is number of hours. Let's call him N. The number of hours decides or tells the dependent variable what to do, and that's the amount of money. Amount of money. We'll say he's M. So my algebraic rule is going to be, well, the amount of money is equal to the number of hours I work times 7.75. Now this is an algebraic function notation, so let's go ahead and write it in function notation. All you have to do is write it with the n again in parentheses on the left-hand side. Those mean the same exact thing. One's in function notation, the top isn't. So the money that I earn, which is dependent on the number of hours I work, is equal to 7.75 times the number of hours that I work. All right, so the independent variable here is always on the x-axis. So my temperature in degrees Celsius is my independent. He's in charge of the pressure which is also called pounds per square inch, PSI. You'll see this a lot when you guys start driving cars because you have to check your PSI, your pressure, in your tires a lot. So here's my algebraic rule. So let's say that P is equal to pressure and T is equal to temperature. Okay? We know it's going to be pressure equals, and it's based on, we're going to plug in T somewhere over here, the temperature outside. Well, I told you guys this a couple of times. Look at where your graph hits the y-axis. That number, wherever it hits, is the guy that you add or subtract at the end. So remember, it's always blank times T plus or minus some number. It's always this number. So it's plus 10. We've got to figure out the rest. Best thing to do is to, Joyce? Yep. And if you couldn't hear what Joyce said, make a table. So we're going to make a table of our x's and y's, which is our our x's is our t's, and our p's. So our t's and p's are x's and y's. When my temperature is 0, my pressure is 10. When my temperature is 1 degrees, my pressure is 15. When my temperature is 2 degrees, my pressure is 20. When my temperature is 3 degrees, 25. My pressure is 25. So we know that we're going to add 10 each time. So let's see what we have to multiply by. We've got to get from 1 to 15. 1 times 1 plus 10 isn't 15. So let's see, if we multiply it by 5 and then add 10, 1 times 5 is 5 plus 10 is 15. 2 times 5 is 10, plus 10 is 20. So you're multiplying by 5 and then adding 10. If you wanted to go ahead and make this a bigger, where you get the process in there, which a lot of you guys probably still need to do, which is 0, 10, 1, and 15, you can. So we're saying that the input times 5 plus 10 equals 15. And you could do that as well. So here we have our rule. P equals 5t plus 10. Well, how would we write this in function notation? All you do is add a little parentheses and write your t again. And you've got function notation. Function notation is not as scary as it looks. All it means is that the pressure is dependent upon the temperature, and the pressure is equal to 5 times the temperature plus 10 more. This trick of looking at the graph and knowing that this number, wherever your line crosses the y-axis, is what you multiply or what you add at the end, will definitely help you a lot, especially when it comes to finding these rules. All right, we'll go to part 2 in a second.